Hello everybody. So this again, as I mentioned in the previous video, this is going to be a quick review on the history of the exploration of the atomic structure. So it started by John Dalton. He suggested, which is this guy, he suggested that there is something that's called atom, and he mentioned that these atoms are responsible for the reactions between the different elements forming molecules. And then Henry Cavendish, he explored hydrogen, and he studied the ratios between the volume of the reactants and products, and he told that there is some ratio, it's not just reacting anything together. And then Gay Lustig, he confirmed the Cavendish findings by doing other experiments on different elements. And then it started to get more clear, and we got more solid results by the experiment done by Sir William Crookes, and he developed or invented the cathode ray tube, and he showed that if you give energy to the atoms in low vacuum, the electrons will be kicked out of the atom, and they will form this glow that we saw before, and this glow is the electrons coming out of the atoms. And then Sir Joseph John Thomson, he said that or he did more modifications to the cathode ray tube, and he applied electric magnetic field and magnetic fields to the electron beam, and he was able to make the electron beam go through slits so it goes into straight line, and he could use the electric and magnetic forces to deflect the beam and return it back to its original place, and he was able to calculate the charge per unit mass of the electron. Then Robert Millikan was able to do his oil drop experiment, and he was able to calculate the charge of the electrons and the mass of the electrons. In the kind of closer times, Roentgen was able to do more experiments on the cathode ray tube, and he observed the existence of X-rays, and he was able to use it to see the bones of the human beings. In the same time, Henri Becquerel and Marie and Pierre Curie were doing experiments on radioactive materials, and they discovered the radioactive behaviors of elements and the nature of radiations and radioactive materials, and they explored found elements that were not known before, like polonium. And then we mentioned that we knew about, or they knew about the alpha, beta, and gamma particles, and alpha particle was used later in many experiments for the exploration of the neutrons, as we mentioned before. And then Hans Geiger, Ernest Marsden, and under the direction of Ernest Rutherford, so this is the Rutherford, this is Geiger, this is Marsden. They did the magnificent experiment for the gold leaf, or using the gold leaf, and they proved that bombarding the gold leaf with alpha particles showed that the atom has huge space, a lot of space, and the model that was done by or put by Rutherford was proved to be wrong, and they started to develop the more realistic model of the nucleus and the electrons rotating around the nucleus. And then the next is the Francis Aston. He invented the mass spectrograph, which was a very, very, very important invention, and he used it to calculate the atomic mass accurately, and it is the base of the mass spectrometer that is used till now. And then James Chadwick, he used the alpha particles and bombarded the beryllium. He found that carbon is produced, and a neutron was coming out of this reaction, and the neutron kind of answered many questions. That we have neutrons here. The neutrons can explain why we have atomic masses that are different for the same element, why, or fractions. And it could explain why the atomic mass is different from the mass of the protons. And then Moseley, he developed his law, and he showed that it's easier, or it's more practical to use the atomic number, which is the number of electrons or the number of protons, to describe the element rather than using the atomic mass as it used to be used before. Finally, the Bohr's model was developed by Niels Bohr, that mentioned that the atom has energy levels, and in these energy levels the electrons can move between them. He showed the energy is h, which is Planck's constant, multiplied by nu, which is the energy needed by electron to travel from one energy level to another. And then Pauli put his principle that the no two electrons in the same atom can have the same four quantum numbers. Erwin Schrödinger, he developed the wave function. He describes the motion of atoms and subatomic particles. And finally, Heisenberg, he proved mathematically that it is impossible to predict the momentum and position of an electron simultaneously. This is all the scientists. These are the scientists that we mentioned in the like last 8 videos. Of course, there are more scientists who had more very important contributions to this field. I'm just mentioning the milestones, the important parts of it. There are many scientists that did more contributions, but again, for the sake of the time limits, and for just not going into more details that might not be of interest to the students taking this course. So this is what I saw is enough to mention. So in the next video, we're gonna start talking about the periodic table, and to see how the periodic table looks like this, and how it's important for us to know the periodicity of elements and the early attempts to develop a periodic table. So this is what we're gonna see in the next video, inshallah. Goodbye.